Good morning, good evening. Today we're going to look at chapter 3, which is about computer specifications. In this chapter, we'll look uh, the following learning outcomes. We'll define terminologies used in the typical personal computer specifications. Then we explain the likely business uses of a computer with particular specifications, and then write specifications for a computer relevant for a particular office task. So, first of all, let us look computer specification in a form of pictures. Basically, this represents some of the main components of a computer system, and at the same time regarded as computer specifications. Like you see, you have the monitor there, the CPU, the RAM, the GPU, and the hard disk drive. So we're going to explain in detail what each component means in the context of computer specifications. So firstly, let's define what computer specification is all about. Here I've given you a short, brief definition which states that computer specification, also regarded as computer hardware and software specification, refer to the technical details and capabilities of a computer's hardware and software components, which are usually presented in the form of numbers or ratings, and they provide information about the computer's performance, storage capacity, and other key features. Let's understand these computer specifications terminologies through the use of this simple table on the slide. The first terminology is called processor or CPU. The meaning of CPU, which is an abbreviation in that case, in full is regarded as central processing unit, which is a component of a computer system responsible for executing instructions that are measured in gigahertz, and cores, which basically means number of processing unit in that CPU chip. Example would be iCore 5, AMD Ryzen 5000, or AMD Ryzen 5. The second component or part of a computer system is regarded as RAM, which is a random access memory. A random access memory is a component of a computer that temporarily stored or that temporarily store information while the computer is actively running. That is, it is temporary storage for data being actively used. It is measured in gigabytes, and normally we say if you have more RAM, you will have better multitasking opportunities. Storage, permanent data storage, e.g. hard disk drive, solid state drive, and solid state drive is more faster as compared to the HDD, but at the same time very expensive. GPU, graphics processing unit, is another component which basically handles graphics rendering. It is an important component because users can use it for designing graphics, for playing games, online games, and also for video editing tasks. Continue with our table that describes the different terminologies. We have operating system or OS, which is a software that manages hardware and software resources like Windows 11, Macintosh operating system, and Linux. So these are the operating systems that are currently in the market. And then we have clock speed. Clock speed is basically explaining the speed at which the CPU processes data, which is measured in gigahertz. And then cache memory, a high-speed memory inside the CPU for frequently used data, ports and connectivity, physical interfaces such as USB, HDMI, Ethernet, wireless options, which include Wi-Fi and Bluetooth, form factor, we have physical size and shape of the computer, such as a desktop, a laptop, or mini PC. Power supply unit, this is a component that provides electrical power to the computer, is measured in watts. Then let's move on to the other item. Here, let's talk about the likely business uses of a computer based on specifications. So we'll try to figure it out in a form of specification level and then possible business uses. So at the lower end, we'll need a computer with dual core CPU and a 4 GB RAM, 128 GB SSD storage. So the possible business use of such specifications under the low end is that you can perform basic office work, word processing, spreadsheets, emailing, and internet browsing. Whereas in the mid-range specification level, you'll need a quad-core CPU with 8 GB RAM and 256 GB of SSD storage. Here, the business can use it for data entry, data management, presentations, online conferencing like video conferencing, teleconferencing, and even telecommuting. Whereas on the high end, we'll need a hexa-core CPU with 16 GB plus of RAM, 512 plus of SSD storage, and a dedicated graphics processing unit. So here the business uses would be for graphic design, video editing, software development, engineering simulations. To have more information about the CPU, let's look at this CPU basics, which basically translate to say in computer specification terms, in computer specifications, terms like dual-core, quad-core, and hexa-core CPU describe the number of independent processing units, that is cores, inside the computer central processing unit. So the CPU basics, the central processing unit, is the brain of the computer. Cores. Cores are individually processors within the CPU that can work independently together to handle tasks. More cores generally mean better multitasking and the ability to handle more complex or multiple operations at the same time. Core types in the context. Let's start with the dual core, what it means. Two cores in a single CPU chip can handle two tasks simultaneously without significant slowdown, suitable for basic tasks like word processing, web browsing, and simple office applications. Whereas the quad-core CPU means 4 cores in a single CPU, which can handle 4 tasks in parallel, improving performance for multitasking, good for heavier workloads like spreadsheets, light video editing, and multitasking with multiple applications. Hexa-core CPU, 6 cores in a single CPU, handle 6 tasks at once efficiently, better for demanding applications like data analysis, larger databases, design software, and moderate 3D rendering. Why core count matters in office tasks is because with dual core, it might be enough for simple office tasks, since it allows you to perform 2 tasks simultaneously. Quad-core is better for multitasking with more demanding programs, and then hexa-core is recommended for specialized roles, e.g. occupational health and safety officer processing big data reports or running analytical tools. Examples in a spec sheets means Intel Core i5 1135G7 quad-core processor. Means that it has 4 processing cores running at a base speed of 2.4 gigahertz. Then specifications for a computer relevant for a particular office task like graphic design would require a processor for Intel Core i9, AMD Ryzen 9, RAM 16 GB, storage 512 GB SSD plus, and then 1 terabyte HDD. If you're using HDD, you'll need 1 terabyte instead of 512 GB. GPU, you'll need NVIDIA GeForce GTX 1660 or higher. Display, you'll need 25 inches of screen display, and operating system, you'll need latest operating system like Windows 11 Professional. Pause, you'll need USB 3.0, HDMI, SD card reader. Those are the specifications for a computer used by a graphic designer. Then with the specification for an occupational health and safety officer, you'll need an Intel Core i5 12th generation AMD Ryzen 5000 series. Reason being, provide enough processing power for multitasking, office software, and safety management tools without lag. Then the memory, which is the RAM, you'll need 8 GB RAM, DDR4 RAM, expandable to 16 GB. Reason being, it will allow you to support smooth running of multiple applications, including spreadsheets, safety data analysis tools, and video conferencing. Storage, you'd need 512 GB solid state drive. Reason B, it allows you to have faster boot up and quick file access. Has enough space for storing safety documents, images, videos, and reports.